Hello friends, I welcome to all of you in medterminal.com. We are going to discuss about development of heart. Before going in detail, please make sure about few lines in your mind that are these are heart develops from lateral plate mesoderm. I repeat, from lateral plate mesoderm or splanchnopluric mesoderm around 18th day or third week of embryonic life. Okay guys, lateral plate mesoderm is splanchnopluric mesoderm on 18th day from third week. At splanchnopluric mesoderm, first of all, there is formation of cardiogenic area. This cardiogenic area form two heart tube. These two heart tube unite each other and form a single heart tube which goes in serial dilatation and constrictions, forms four chambered heart. These serial and dilatations were shown in this diagram, in the first diagram. If you see it carefully, the upper end is red, which is arterial end actually, while the lower end is venous end. This venous end represents sinus venosus plus primitive atrium. I repeat, this lower venous end is represented by sinus venosus and primitive atrium, and this lowermost end goes posteriorly during development of heart tube, then comes superiorly, going posteriorly and then comes superiorly like this, and now it is known as primitive atrium. So let's start. As we all know, after fertilization it forms zygote, and this zygote after cleavage forms 2 cell stage, then 4 cell, and further cell division makes 8 to 16 cell and then 32 cell stage. This 32 cell stage is known as morula. Further, this morula differentiate in such manner that it forms a outer cell mass and inner cell mass. Outer cell mass will provide nutrition to the inner cell mass, which will form future embryo proper. This is the inner cell mass. Please see, this is the inner cell mass, while this is the outer cell mass which will form trophoblast and give nutrition to the embryo proper. This is the story till 7th day or the first week. In the second week, which is actually bilaminar disc formation week, this embryo proper will convert into two layers. First, outermost is epiblast, which is toward amniotic cavity, while lowermost is hypoblast, which is toward yolk sac. This hypoblast and epiblast bilaminar disc will convert into trilaminar disc in the third week. This trilaminar disc is now known as gastrula, and this trilaminar disc is made up of ectoderm, mesoderm and endoderm. We are aware. Importance of this whole story up to 3 weeks. Actually, I want to make a picture about these three layers: ectoderm, mesoderm and endoderm. This endoderm is toward yolk sac, which will form GIT in future, while this ectoderm will form neural plate, from which spinal cord and brain will develop, while at the mid layer, which is known as mesoderm, our area of focus is this mesoderm. This mesodermal parts will further divide into three parts, and the lateral most part, which is actually lateral plate mesoderm, which is divided into two parts, is splanchnoplure mesoderm and somatoplure mesoderm. Somatoplure mesoderm is toward ectoderm, while the part of mesoderm which is toward endoderm is known as splanchnoplure mesoderm. This splanchnoplure mesoderm will form heart tubes or vascular parts. So my area of focus will be this splanchnoplure layer. I am again showing this trilaminar disc in my next diagram, so that you have a better view about lateral plate mesoderm and splanchnoplure mesoderm. Please have a look of this is trilaminar disc. Outermost layer is ectoderm, middle is mesoderm which is our area of focus, and this is endoderm which is toward yolk sac. This endoderm will form future GIT, very simple, while this ectoderm will form future brain and spinal cord, and this red middle layer is here shown. If I am taking a cut section from this like this, if I am taking a cut section like this, then I can show all three layers like this. This is the outermost ectoderm, no problem. This is ectoderm, and the innermost is endoderm. This endoderm will form GIT, while this ectoderm will form brain and spinal cord. This mesodermal layer have three parts. This is the axial mesoderm which will form notochord. Near axial mesoderm, this pink one is paraxial mesoderm. This paraxial mesoderm will form somites. Near paraxial mesoderm, this is known as intermediate mesoderm. This will form future kidney and gonads. And lateral to this hole is our lateral plate mesoderm. Okay guys, this hole is lateral plate mesoderm. This lateral plate mesoderm will further subdivide into two parts by forming a cavity. This cavity is now known as intraembryonic xylem. This mesoderm is fully divided. See this intraembryonic xylem. This is intraembryonic xylem. This one. This is intraembryonic xylem. This intraembryonic xylem divides lateral plate mesoderm in two parts. The part of mesoderm which is towards ectoderm is known as somatoplure mesoderm. Simple. And the part of mesoderm which is toward endoderm is now known as splanchnopluric mesoderm. So our area of focus is this part of lateral plate mesoderm, which is actually known as splanchnopluric mesoderm, how it forms heart tube and other vascular parts. I have already explained this lowermost yellow layer is endoderm, which will form GIT. Under influence of this endoderm, actually what happens, it starts secreting VEGF, which are known as vascular endothelial growth factor. Under the influence of this VEGF, this layer of splanchnopluric mesoderm starts expansion. Not only it is starting expansion, but also there is development of vascular cords like structure, vascular cords or angioblastic cords in whole splanchnopluric mesoderm. Angioblastic cord cell development. These angioblastic cord cells form a heart tube at cranial part of mesoderm. At cranially it forms the heart tube, and the other part it will form vascular parts like dorsal aorta and other vasculogenesis happens under the influence of this VEGF, which is secreted through endodermal layer. Okay friends, shall we move ahead? Shall we move ahead? Clear? Under the influence of VEGF, which is secreted through endoderm, splanchnopluric mesoderm starts development and it will form heart tube at the cranial part of buccopharyngeal membrane, and other part will take participation in the dorsal aorta and other vascular parts. Now what happens when this splanchnopluric layer develops comparatively more, it gets start elongation at both poles. Because of this elongation, there is folding starts. This folding is known as lateral folding. Because of this lateral folding, this germinal disc forms a circular structure. Initially this was like a planar structure. Because of this lateral folding, these two poles come closer to each other and forms a circular structure. These two poles come closer. Under this factor of lateral folding, the innermost layer, which is known as endoderm, starts forming GIT and get invaginate inside and getting separated from yolk sac like this. It is getting invaginated inside and also separating from yolk sac because these two heart tubes are coming closer. These two heart tubes are coming closer because of lateral folding. These are the two heart tubes which are coming closer because of this lateral folding. As I have already explained, this is the intraembryonic coelom. This intraembryonic coelom have two layers. The part of mesoderm which is toward ectoderm is known as somatopleure mesoderm, while the inner part is known as splanchnoplure mesoderm. So if it is pericardial cavity, inside it is splanchnoplure, while the outer layer of this pericardial cavity is somatoplure layer. Simple. Pericardial cavity is always surrounded with two layers. Inner layer is splanchnoplure like this, and the outer layer of this cavity will be somatoplure layer, this. Further, more invagination occur and these two tubes come more closer, and heart tube come closer. Because of this, GIT goes more posteriorly. And if we see relations of GIT with respect of these two heart tube, then initially this heart tube is connected to these two heart tubes via a layer of mesoderm. This mesoderm is now known as dorsal mesocardium. Dorsal mesocardium. This layer of mesoderm is known as dorsal mesocardium. Okay, friends? Dorsal mesocardium. And anteriorly, this heart tube is surrounded by pericardial cavity, inner layer and outer layer. Inner layer, we are aware that this inner layer is formed through splanchnoplure mesoderm, splanchnoplure, while the outer layer is formed by somatoplure mesoderm, somatoplure mesoderm. Further, this dorsal mesoderm starts degeneration. Because of this degeneration, this pericardial cavity starts surrounding completely, almost completely to these heart tube. But there is a gap remains. This gap is now known as transverse pericardium, transverse sinus of pericardium or transverse pericardial sinus. If we see very carefully, I will explain it later. Actually, heart tube is like this. This end is venous end. and this is arterial end. I will explain it in craniocaudal folding. I will explain this in craniocaudal folding that heart tube is like this. This end is lower end. I have explained lower end is venous end, while upper end is arterial end. This tube is start invaginating in pericardial cavity like this. Initially, this tube is connected to foregut via this dorsal mesocardium. But after degeneration of this dorsal mesocardium, this forms what? Transverse pericardial sinus. So, transverse pericardial sinus is present between these two ends, this arterial end and this venous end. And this is the truncus arteriosus, which will form future ascending aorta and pulmonary trunk. What is the importance, clinical importance of this transverse pericardial sinus? This question is asked frequently in MCQs. Clinical importance of this transverse pericardial sinus is that during heart surgery, a cardiothoracic surgeon places a finger and he separates the inflow of blood with respect to the outflow of blood. Just make an image that he is putting a finger in transverse pericardial sinus and differentiate the two ends of heart tube in which blood is getting inflow and getting out through pulmonary trunk and ascending aorta and getting in through superior vena cava. I am showing this transverse pericardial sinus again in this diagram, that heart tube is synced or invaginated into this pericardial cavity. This is the venous end, this is the arterial end, and this is the transverse pericardial sinus. I will explain this diagram later on. Let's move about craniocaudal folding or the head folding. For better explaining head folding, please have a look of mesoderm. I have explained that this is mesoderm central part which will form notochord, and the cranial part is of notochord is prochordal plate or buccopharyngeal membrane which will form future mouth, and the posterior most part is cloacal membrane which will form future anus, and this is the primitive streak. Near axial mesoderm, this line is per axial mesoderm which will form somites, and this is intermediate mesoderm which will form gonads and kidney, and this whole part is lateral plate mesoderm. This lateral plate mesoderm get divided into two parts through a coelom. This is intraembryonic coelom. Into two parts. First part, which is internal or towards endoderm, is known as splanchnopleural layer of mesoderm, while the outer part, which is toward ectoderm, is known as somatopleural mesoderm. If we look very carefully, that this intraembryonic coelom is surrounded by two layers of mesoderm. Inner is splanchno, while outer is somatopleural layer of mesoderm at every place. The cranial most part of this intraembryonic coelom, which is near prochordal plate, is a specific part. The part of mesoderm which is cranial to prochordal plate Under the influence of VEGF which is secreted through endoderm, these mesoderm will form heart tubes. These mesoderm will form heart tubes. I repeat again, cranial to oropharyngeal membrane or this prochordal plate or buccopharyngeal membrane, mesoderm will form heart tube, and cranial to this coelom will form pericardial cavity, and the cranial most part is this septum transversum. Okay friends, so I explained about these three structures. Cranial to this buccopharyngeal membrane is heart tube, then pericardial cavity forms, and the cranial most is septum transversum. I am showing all three structures again. If I am taking a cut section from here like this, if I am taking a cut section from here, then you will see what septum transversum, this pericardial cavity and heart tube at cranial most part, then buccopharyngeal membrane, and then all three structures. So here are our these three structures which I just explained. Cranial most is septum transversum first, and this is our buccopharyngeal membrane. Cranial to buccopharyngeal membrane is heart tube with pericardial cavity. This is the pericardial cavity. This is the ectoderm part which will form future brain and spinal cord. Below it is notochord, and this is the lowermost part which is endoderm, and below it is yolk sac. Now what happens? Brain enlarged comparatively more than the rest of the body, like this. Because of brain more development, it starts banging upon itself. Because of this, what happens? The cranial most, these three parts, the cranial most part or cranial part which is cranial to buccopharyngeal membrane starts shifting inferiorly, and finally it comes in the chest cavity like this. Initially heart is at cranial part, but when brain develops comparatively more to the rest of the body, then this heart with its heart tube or pericardial cavity with septum transversum starts going in the chest cavity. Septum transversum goes caudal to the heart tube. This septum transversum will form future diaphragm, mesentery, and fibrous pericardium. Fibrous pericardium or covering of heart. So I have explained three covering of heart. What are these three covering? Fibrous pericardium, outermost, which is formed through septum transversum. Second covering is pericardial cavity, which have two parts. Parietal pericardium outer layer formed through somatopleural layer, and the inner layer is splanchnopleural mesoderm, which is known as visceral pericardium. And purpose of explaining this head folding is this: heart develops initially cranially, and finally in the definitive position it goes in the chest cavity with its septum transversum at caudally presentation, while pericardial cavity is anteriorly. If you look this diagram very carefully, then you can understand that during this head folding, endoderm starts folding upon itself. I have explained in lateral folding as well, and this endoderm will form foregut. This is our buccopharyngeal membrane. This is our buccopharyngeal membrane, and this endoderm will form not only going posteriorly and forms foregut, also start separation from this yolk sac. And here is our heart tube lower end. This lower end is venous end. This lower end is venous end, while the cranial end is arterial end. Initially, this heart tube is connected to foregut via dorsal mesocardium. Here is our dorsal mesocardium. But after degeneration of this dorsal mesocardium, this will form transverse pericardial sinus, which will separate the upper arterial end to the lower venous end posteriorly. Shall we move ahead? This is the same concept which is showing lateral folding and craniocaudal folding. Purpose of lateral folding is this: these two heart tube after lateral folding starts meeting each other, and this endoderm will start invaginating, and this will form foregut. And in the starting, when these two heart tubes come closer, foregut is connected to this heart tube posteriorly via dorsal mesocardium. After degeneration of this dorsal mesocardium, it will form transverse pericardial sinus, which is separating heart tube two portions: anterior portion, which will form truncus arteriosus or pulmonary trunk or aorta, and the posterior most portion, which will form SVC. This is diagram which is showing actually initial development of heart tube, which is cranial to buccopharyngeal membrane. This is buccopharyngeal membrane and this is cranial to buccopharyngeal membrane, and the cranial most part is septum transversum. After head folding, I am showing in next diagram. After head folding, this is our head, and cranial to notochord is oropharyngeal membrane, and cranial to oropharyngeal is this pericardial cavity with heart tube, and the cranial most part is septum transversum. This is the septum transversum. When this head starts developing comparatively more than the rest of the body, these whole three structures, heart tube with pericardial cavity with septum transversum going toward chest cavity. Septum transversum comes here and it will form future diaphragm, liver, mesentery, and one part of heart, that is fibrous pericardium. And this structure is our smart pericardial cavity. This pericardial cavity is initially covering anteriorly, but later on it covers fully this heart tube. Okay friends, again the lateral folding is showing. Purpose of this lateral folding is this, so that you people and you guys can make a clear picture that this foregut is posterior to the heart tube and initially connected via this dorsal mesocardium, and after degeneration of this dorsal mesocardium, it will form remnant of dorsal mesocardium or transverse pericardial sinus. This transverse pericardial sinus is separating truncus arteriosus to the inflow of blood, means truncus arteriosus is getting separated to the sinus venosus via this transverse pericardial sinus. This is the inflow of blood, caudal, and this is our cranial end. Okay friends, shall we move ahead? This is our heart tube. This heart tube starts dilatation and some constrictions and form 5 parts. What are these 5 parts? First sinus venosus, then primitive atrium, and above primitive atrium it is primitive ventricle, then bulbus cordis, this is the bulbus cordis, and uppermost part is truncus arteriosus. I repeat 5 parts. First is sinus venosus, second is primitive atrium, third is primitive ventricle, fourth is bulbus cordis, and fifth is truncus arteriosus. The lowermost part is venous end. This is the venous end of the heart tube, and the uppermost part is the arterial end of heart tube. Arterial end of heart tube means blood starts flowing from lower to upper side. Why blood is flowing? I want to make one more concept in your mind. This is the first functional organ. This is heart is first functional organ. Why first functional organ? Because around 18th day or around third week, actually embryo size is big enough. Embryo size is big enough so that it requires nutrition. Up to second week, it is getting nutrition through trophoblast layer. But in the third week, embryo size is big enough that it requires its own blood supply. Own blood supply which is very efficient, hence it has to make its heart tube with vasculogenesis. So in the 18th day, it forms two heart tube. Then around 20 day, it forms single heart tube. 21 day, it is dilatations and serial dilatation and constriction seen in the heart tube, and around 28th day a four chambered heart like this forms. And further, in the 5th week to 7th week, atrial septum development and ventricular septum development and spiral septum development. Three septum I have told: atrial, ventral, and this tube septum is spiral septum develop. This is spiral shaped septum. I will explain it later. Forms in 4th to 7th week. Up to 4th week, this four chambered heart structure formed. Okay friends. So question is, heart tube is formed in hyaluronic acid secreted by myocardium. I yet not explained about hyaluronic acid or cardiac jelly. Please look this diagram again. This is the endocardium of heart tube. And what is this? This is a splanchnopluric layer of mesoderm. This splanchnopluric layer mesoderm around this heart tube. This splanchnopluric layer mesoderm around this heart tube starts secreting a jelly-like fluid, which is actually hyaluronic acid, is known as cardiac jelly. And this remaining mesoderm and the mesoderm which is around cardiac jelly will form myocardium and epicardium. Epicardium, we are aware, in the innermost layer of visceral pericardium, innermost layer or the visceral pericardium. This whole structure, these two structures, myocardium and epicardium, is known as myoepicardial mantle. So cardiac jelly is secreted through this myoepicardial mantle. So heart tube is formed in hyaluronic acid secreted by myocardium. Heart tube is formed at third week. Heart is fully developed at end of third month. End of third month. Please remember, start at third week, completely developed at third month. It develops from splanchnic mesoderm, lateral plate mesoderm, cranial to procaudal plate or buccopharyngeal membrane or oropharyngeal membrane, and near it is septum transversum is developed. Septum transversum will form future diaphragm, mesentery, liver, and fibrous pericardium. Fibrous pericardium. This fibrous pericardium is outermost covering of heart. Venous end of heart tube, which is caudally known as sinus venosus. Simple. Above sinus venosus is primitive atrium. These are the venous end. Sinus venosus is primitive atrium. What this diagram is indicating? This diagram is indicating, first, the lowermost part is the venous end, which is receiving blood through three sets of vein. What are these three sets of vein? If we see, this is yolk sac, and the yolk sac vein is known as vitelline vein. Why vitelline vein? Because in Hindi, yolk sac is known as egg pitti or egg pit. So yolk sac vein is known as vitelline, and English yolk sac meaning is vitelline. So vitelline vein from yolk sac, and from maternal blood through placenta is coming through. This is umbilical vein. Simple. This is umbilicus. This is umbilicus or placenta. So this vein is umbilical vein. And the rest of the body through this anterior and posterior cardinal vein opens into first in common cardinal vein and finally into the horn. So purpose of this diagram is this: the lowermost end, which is actually sinus venosus opening into primitive atrium, this sinus venosus have two horns. This sinus venosus have two horns. Each horn of sinus venosus is receiving blood. Each horn of sinus venosus is receiving blood through three sets of vein. What are these three sets? The middle one is vitelline vein, then umbilical vein, and then common cardinal vein. And this common cardinal vein drain blood from whole body through anterior cardinal vein and posterior cardinal vein. This is the left horn and this is the right horn. Same at the right side. This is vitelline vein, then umbilical vein, then common cardinal vein. Okay. Then from this sinus venosus blood goes into the primitive atrium, then primitive ventricle here, then bulbus cordis, then truncus arteriosus. And from truncus arteriosus, this blood is going to dorsal aorta via aortic sac and aortic arches. We will discuss in another lecture. But I have explained not only heart tube is forming, but in splanchnopleuric mesoderm, vasculogenesis is also going on at the same time to give nutrition to the embryo, as heart is the first functional organ in embryo. Okay friends, this heart tube was initially here along with this pericardial cavity and septum transversum here, but after brain development this heart tube goes in chest cavity and septum transversum will be here. This septum transversum will form diaphragm, liver, mesentery and fibrous pericardium. This is the lower pole of heart tube, which is having right horn. This is the right horn and left horn, right horn, left horn. What is this? This is sinus venosus, which is opening into primitive atrium. Primitive atrium is opening into primitive ventricle, then bulbus cordis. This is the bulbus cordis, and bulbus cordis is opening into truncus arteriosus. Okay. And if you see very carefully, this truncus arteriosus is opening. This is truncus arteriosus is opening finally into the dorsal aorta. Dorsal aorta is actually in posterior view, so we are not able to visualize dorsal aorta, but please make an image that this truncus arteriosus is connected through aortic arches via aortic sac finally to the dorsal aorta, to dorsal aorta. These are our 5 parts of heart tube: sinus venosus, primitive atrium, primitive ventricle, bulbus cordis and truncus arteriosus. Now what happened? In the next part, this bulbus cordis start developing comparatively more. It develops in such a way that it is not getting enlarged, but it is also shifting in the rightward direction and lower direction, rightward and downward direction. This is very important concept, guys. You can listen or you can repeat this sentence around 100 times if I explain this thing to 12th standard guys. that bulbous cordis is developing in such a manner that bulbous cordis comes in the downward and rightward direction. Downward and rightward direction. Please see. Bulbous cordis comes in the downward and rightward direction. And then primitive ventricle itself starts shifting in the left side. This is the primitive ventricle. Lower pole I yet not discussed. Please forget about this lower end, which is having sinus venosus with primitive atrium. Please forget for a moment. Just concentrate on bulbous cordis and this primitive ventricle. Bulbous cordis comes to the downward and rightward direction. Primitive ventricle shift to the left side. This bulbous cordis will form future right ventricle and this primitive ventricle will form future left ventricle. Simple. And above is truncus arteriosus, which is actually opening in both these cavities. Now, bulbous cordis and ventricular cavity. Now, this is combinedly known as bulboventricular cavity. Bulboventricular cavity, in which truncus arteriosus is opening at the central. I am going to repeat again because this is very important concept. Without this concept, heart formation is incomplete. So I will repeat again the whole things, don't worry. This is our lateral plate mesoderm, splanchnopleural part, where two heart tubes start forming. These two heart tubes form one heart tube around 21 day, and there is 5 dilatation. These are 5 dilatations: sinus venosus, primitive atrium, primitive ventricle, bulbus cordis, and truncus arteriosus. This truncus arteriosus is connected to dorsal aorta via aortic arches and aortic sac to dorsal aorta. These are two dorsal aortas. Now forget about this aortic sac and dorsal aorta. Just concentrate on these 5 parts. What happened with these 5 parts? If you see very carefully, sinus venosus is opening into primitive atrium through sinoatrial orifice. Simple. This is sinoatrial orifice. Sinoatrial orifice. Orifice is simple a opening, and sino means sinus venosus and atrial is primitive atrium. So it is sinoatrial orifice. And primitive atrium is opening into primitive ventricle through atrioventricular canal. Single atrioventricular canal. This is atrioventricular canal. This, please look here. This is atrioventricular canal. Now what happens? As I told that bulbous cordis start developing comparatively more in such a way that it starts shifting rightward and downward direction, and primitive ventricle starts shifting toward left side. So it take this position. After shifting right and down by bulbous cordis, which is actually future right ventricle, and primitive ventricle shift toward left side, which is actually left ventricle now. See here again, primitive ventricle shift to the left and bulbous cordis after development shift to the right and downward direction. Why this type of special movement occur? Because of dynein protein. This movement is known as dextrolooping. This is known as looping of heart. This looping occurs in the 23rd or 24th day. Okay guys? Around 18th day 2 heart tubes form. Around 20 day complete heart tubes forms. 21 day they will form 1 heart tube. 22nd day 5 dilatation seen. Around 24th day looping because of dynein protein occurs. Because of this looping, the mid portion, which is composed of bulbous cordis and primitive ventricle, take its definitive position as right ventricle and left ventricle. Now what happened with the lower pole? lower pole, which is composed of primitive atrium and sinus venosus, this lower pole goes posteriorly. This is a difficult part because I cannot explain how posteriorly a tube is going. You have to assume if this is a tube, it is going posteriorly like this, then it is forming a U-shaped tube. It is going posteriorly, not only going posteriorly, but after going posteriorly, it starts enlarging like this. When it starts enlarging after going posteriorly, it starts projecting like this from the truncus arteriosus. As I have already told that this pole, this is the lower pole which is going posteriorly like this. This is primitive atrium and this is sinus venosus. This pole is going posteriorly and then it starts enlarging in such a way that it starts projecting through truncus arteriosus. This is the truncus arteriosus. And primitive atrium starts projecting through truncus arteriosus. And we are also aware that primitive atrium is connected to sinus venosus with its two horns. These are two horns. Again, the same diagram. This is the primitive atrium with its two horns, right horn and left horn, receiving three sets of vein. We have discussed about sinoatrial orifice, means sinus venosus is opening into primitive atrium through sinoatrial orifice, and primitive atrium is opening into primitive ventricle through atrioventricular canal. Now have a look. This is the anterior look in which we can able to see truncus arteriosus with bulbus cordis and ventricle, bulboventricular cavity with truncus arteriosus. But to see primitive atrium with sinus venosus, we have to see this heart tube from posterior side. This is the posterior view of heart tube. What is this? This is primitive atrium, enlarged lowermost portion, which is having primitive atrium with sinus venosus. This is sinus. This whole is sinus venosus. We are aware that sinus venosus is having two poles. These are right horn and this is left horn. This is right horn and left horn. Each horn is receiving three set of vein. Medial one is umbilical vein. This is umbilical vein. Then medial most is vitelline vein, which is receiving blood through yolk sac. Then umbilical vein, and this is the common cardinal vein, which is receiving blood through anterior and posterior cardinal vein. And what is this? This is very important opening, which is known as sinoatrial orifice. Means this sinus venosus is opening in primitive atrium through this opening, which is known as sinoatrial orifice. Sinoatrial orifice. Okay, friends. What is this? This is sinoatrial orifice. Shall we move ahead? This is the anterior view. This is lateral view, in which blood is going. Lateral view, blood is going from lowermost portion to the upper portion and finally into the aortic sac. This is sinus venosus lowermost portion, which is connecting through sinoatrial orifice to the primitive atrium, and from primitive atrium through atrioventricular canal opening into the primitive ventricle. From primitive ventricle, blood is going to the bulbus cordis and then truncus arteriosus. If we see this tube from anterior view, then this will be seen. These are our projected lowermost portion, which is having primitive atrium with sinus venosus. Here is our beautiful sinus venosus. And what is this? This is the middle part of tube, which is having bulbus cordis, which comes to the rightward and downward direction, and this is our primitive ventricle, which goes to the left side. This is bulbus cordis is actually future right ventricle, and this primitive ventricle is future left ventricle. Simple. This is the posterior most part, which is actually lowermost part of the tube, which is not only going posteriorly like this, but it starts projecting through truncus arteriosus. And when we see this primitive atrium posteriorly, then this is the primitive atrium. And what is this? This is truncus arteriosus. In this primitive atrium is receiving blood through sinus venosus. This is sinus venosus. So this is sinovenous opening. Sinoatrial orifice. Sinoatrial orifice. Each sinus venosus is receiving blood via two horns. This is the right horn, this is left horn. And each horn is receiving blood through three sets of vein, which is Witte, Umbi and common cardinal vein. Now we are going to discuss about endocardial cushion development, because it is very important to learn about this endocardial cushion development, because if we are not able to understand this development, then our septal development, what are the three septas? Atrial septal development, then ventricular septal development, and third is spiral septal development, will be incomplete without understanding formation of endocardial canal, endocardial cushion, sorry. We are aware that this is primitive atrium, which is opening into bulboventricular cavity through atrioventricular canal. Here is our atrioventricular canal. Now what happened? One anterior cushion and another posterior cushion, which is known as ventral endocardial cushion and dorsal endocardial cushion, they start developing toward each other, and finally they form a single fused endocardial septa. This is the fused endocardial septa. After forming this fused endocardial septa, a single atrioventricular canal is now divided into two parts. First is, this one is right atrioventricular canal, and this is left atrioventricular canal. I cannot explain 3D formation of this endocardial cushion antero-posterior direction, so I am trying to explain this through pelvic cavity. We are aware that this is the posterior part of pelvic cavity, which is formed through sacrum, and this is the anterior part of pelvic cavity, which is pubic. If a septum starts developing from posterior side and anterior side, and it is developing to each other, and finally they meet each other, they will divide this cavity into two parts. This will become the right canal and this will become the left canal. Same way here, one atrioventricular canal, this atrioventricular canal is now divided into two parts, right and left atrioventricular canal. As I have explained earlier, that this is the mid portion of our heart tube, which is having bulbus cordis and primitive ventricle, and the lowermost part of heart tube goes posterior and then get enlarged, and it starts projecting through the truncus arteriosus. If I remove this truncus arteriosus, then how I can explain this endocardial cushion? I can explain this endocardial cushion in the mid part. This is also known as septum intermedium. Here is our septum intermedium or endocardial cushion. This septum intermedium is now dividing this atrioventricular canal into two parts. This is the right AV canal, and this is left AV canal. Okay friends, two AV canal formation is done through endocardial cushion development. Now it's time to discuss about common atrial septal development. The purpose of this common atrial septal development is so that we can make this is right atrium and left atrium. This common atrium will be divided into two parts, right atrium and left atrium, after development of this common atrial septal formation. Before going ahead, I want to make two concepts in your mind. The septum which is developing at first time is known as septum primum. Simple. While the septum which is developing at second time is known as septum secundum. Simple. What I told? The septum which is developing at the first time is known as septum primum, while the septum which is developing at the second time is known as septum secundum. And this is mandatory to shift blood from right to left side. Why it is mandatory to shift blood from right to left? Because we are aware that from right ventricle blood will go into lungs through pulmonary trunk. As fetus is not breathing, so lungs are not expanded. As lungs are not expanded, so pulmonary resistance or pulmonary vascular resistance is very high. So very few amount is going toward lungs from this right ventricle. So right ventricular and right atrial pressure get rise. Because of this increased right atrial and right ventricular pressure, as blood is not moving into lungs, this blood of right atrial has to shift in left atrium via any way in the fetal life. For this shifting, it requires foramens. Foramen. The foramen which is developing in the first time is known as foramen primum. Simple. And the foramen which is developing at the second time is known as foramen secundum. If you look very carefully, then I mentioned this foramen primum and foramen secundum in septum primum. What does this mean? This means that septum primum is having all these two foramens, which are foramen primum and foramen septum, foramen secundum. Okay. Now we are going to discuss how this foramen forms. Actually, from the roof of atrium, this is the roof of atrium, one septum starts developing at the first time. This septum is known as septum primum. This is a crescent shaped septum which is developing from the roof of common atrium like this, but it do not touch the endocardial cushion. This is our endocardial cushion here. This do not touch the endocardial cushion. So a gap remains through which right atrial blood shifts to the left atrium very easily. This gap is known as foramen primum, and this is our septum primum. Gradually what happens, this septum primum starts going toward this endocardial cushion. When it is going toward endocardial cushion, this gap starts filling. Before that, there are some fenestrations or pores start developing at the upper pole of septum primum. All these pores or fenestrations meet each other and they form a large opening. This opening is now termed as foramen secundum. Means foramen primum is at the lower pole of septum primum, while foramen secundum is situated at the upper pole or upper margin of the septum primum. Please see here. Blood is going from right side to the left side, no problem. After formation of foramen secundum, another septum starts developing. Now this septum is called as septum secundum. This septum, pinkish, is known as septum secundum. This septum secundum is developing in such a way that it crosses the margins. It crosses the lower margin. This is the lower margin of foramen secundum, it starts crossing the margin of lower, it starts crossing the margin of foramen secundum. Okay friends, and it overlaps the foramen secundum. When it overlaps, still there is a opening. Now blood has to take a oblique course. Before passing from left atria to the right atria. This oblique course or oblique opening is known as foramen ovale. This is foramen ovale. Okay. Okay. Do I repeat again? First what forms? First forms is septum primum. Lower pole it is having foramen primum and the upper pole it is having foramen secundum. After foramen secundum development, this is septum secundum starts developing adjacent to the septum primum or to the right side. This is very important. At the right side of septum primum, this question asks usually. From where septum secundum develops? This septum secundum develops at the right side of septum primum, and it starts growing downward from the roof of atrial chamber to the right of septum primum. When it grows, it come to overlap the free margin. Of septum primum. Once the two septa get overlap, blood has to flow through the interval between the septa. This interval is known as foramen ovale. If you look carefully, then what happens? The upper portion of septum primum, degenerate in the next stage. You are not able to visualize the upper portion of septum primum, and the lowermost portion of septum primum is thin and flappy. So it works like a flap. During fetal life, when blood is going from right to left side, this flap move away like this. So blood can move from right to left easily. But what happens? But when birth take place and lungs start breathing, they put blood into left atrium. So left atrial pressure get rise. Because of this increased left atrial pressure, when blood wants to move from left to right, immediately what happens? This valve, which is thin and flappy, its upper end get fused with the septum secundum. This is the septum secundum. This upper edge get fused with the septum secundum, and now blood cannot move from left to right side. So it is a unidirectional valve actually. Means only it can functional in fetal life. Only in fetal life when right atrial pressure is more, so that it can shift blood from right to left. But after birth, when lungs start breathing, when left atrial pressure get rise and blood wants to move from left to right, it immediately close, because its upper edge of septum primum get fused with the septum secundum and it get closed. Now it will form fossa ovalis in adult. Fossa ovalis, after birth, this foramen ovale will form fossa ovalis, and the foramen secundum will form margin of fossa ovalis, which is known as limbus fossa ovalis. Now I am going to discuss about right atrial development. How right atrial development. Right atria have two part, smooth part and rough part. Easy. Rough part is very easy. Rough part developed from primitive atrium. I will also discuss about, when we will discuss about left atrium. Left atrium, the rough part is developed from primitive atrium, but the smooth part is developed through sinus venosus. How? Let's see this diagram. We are aware that lowermost part is primitive atrium with sinus venosus, which is opening. Sinus venosus is opening into primitive atrium through sinoatrial orifice. This is the posterior view, we are aware. This is primitive atrium which is opening through sinus venosus with its two horns. This is sinoatrial orifice which is actually initially in central like this. But what happens? This is the left horn and this is right horn of sinus venosus. This left horn start degeneration. It start degeneration like this. Because of this degeneration, the sinoatrial orifice, which is actually in central position initially, because of this left horn degeneration, it starts shifting toward right side gradually. It starts shifting toward right side gradually, and finally it comes in the right side in a circular form initially. If you see carefully, this is the anterior communicating vein, this is anterior communicating vein, this is anterior cardinal vein, and this is also anterior cardinal vein of right side, left side. This is posterior cardinal vein. Left side anterior cardinal vein is degenerating and putting its blood through anterior communicating vein, so right horn starts enlarging gradually. Right horn starts enlarging and left horn start degenerating. During enlargement, it starts shifting toward right side as well. And now it will form a valvular structure. This will form left venous valve and this will be known as right venous valve. This whole structure composed of left venous valve and right venous valve is now termed as septum spurium. This question is asked, guys, please be careful. Where septum spurium forms? Septum spurium is formed in right atrium by two valves, left venous valve and right venous valve. As I have explained that left venous valve is degenerating, this left side is degenerating and it gets detached and get merged into the atrial septum. Left venous valve get merged into atrial septum. While this right venous valve, not only right horn is developing more, this right venous valve also get enlarged in such a way that it separates the right horn veins. I will explain here. If you see, this anterior cardinal vein and posterior cardinal vein get enlarged. This anterior cardinal vein will form future SVC now, while this posterior cardinal vein along with this vitelline vein will form future inferior vena cava. And this left horn is actually thick vein comparatively, so it do not degenerate. Left horn tributaries get degenerate, but left horn is quite thick, so it will form coronary sinus. It will form coronary sinus. Coronary sinus is formed from left horn. SVC is formed through anterior cardinal vein. This is IVC, which is formed through posterior cardinal vein and vitelline vein. And the right venous valve will form sulcus terminalis or crista terminalis. I will explain it, don't worry. Sulcus terminalis and crista terminalis. Just in this page, or in this slide, make an image that anterior cardinal vein will form SVC, posterior cardinal vein will form IVC, and left horn of venous sinus is forming coronary sinus, and the right horn venous valve is making crista terminalis. Importance of this crista terminalis is this: it is a boundary line between rough and smooth part of right atrium. What we are reading? We are reading how smooth part of right atrium develops. This smooth part develops through this whole structure. What is this whole structure? This whole structure is sinus venosus with its horn. This sinus venosus with its horn get absorbed into the posterior wall of this primitive atrium and forms a smooth wall, while this primitive atrium forms the rough part. Simple. Please look this diagram very carefully. What is this? This is the rough part of right atrium which is formed through primitive atrium, and this is the smooth part of right atrium which is because of sinus venosus absorption with its horn. Right horn especially get thickened and form SVC through anterior cardinal vein, and this is the IVC, inferior vena cava. It is formed through posterior cardinal vein, and this is the valve of posterior cardinal vein, inferior vena cava, and this is coronary sinus. You are aware, this is coronary sinus which is formed through left horn. This is posterior cardinal vein, this is anterior cardinal vein, and what is this? This is demarcating. Internally is known as crista terminalis. What is this? Crista terminalis is a boundary line between rough and smooth part of right atrium from inside, while from outside it is known as sulcus terminalis. From outside it is known as sulcus terminalis. Please see, this diagram is showing again, this is the smooth part which is developing from sinus venerum or sinus venosus with its two horn, superior vena cava, inferior vena cava, and coronary sinus. Coronary sinus develops from left horn. This inferior vena cava from posterior cardinal vein and vitelline vein also forms portal vein. If you see very carefully through this diagram, I want to make a concept about septum spurium, which is actually right venous wall and left venous wall. This is the right horn and this is the left horn. This left horn will degenerate, but this left horn tributaries will degenerate, but this left horn will form coronary sinus, and left common cardinal vein will form oblique vein of left ventricle. Further, this left venous wall will get fused to the atrial septum, while this right venous wall form crista terminalis internally. These are three openings. You are aware, this is SVC opening, this is IVC opening, and this is coronary sinus opening. I have explained. Now we are going to discuss about left atrial development. Left atrial development, rough part is simple, developed from primitive atrium. How is smooth part develop? This is the question. What is this? This is pulmonary veins. These are four pulmonary veins, 1, 2, 3 and 4. These all four pulmonary veins get absorbed into the posterior most part of the left ventricle. These all four pulmonary veins get absorbed into the posterior most part of left atrium and forms the smooth part of left atrium. Simple. At the time of beginning, when septum primum is just starting, when septum primum is developing, this is the septum primum development. At that time, only one pulmonary vein opens into the left half of primitive atrium. But when we trace away from the heart, the vein divide into right and left branches. If we furthermore trace backward side, then each branch subdivide into two sub branches. Each branch divide into two sub branches, means total 4 pulmonary vein. These all 4 pulmonary vein get absorbed like this into the posterior surface of primitive atrium left part and forms the smooth part. Okay friends? I am going to revise how a smooth part of right atrium develops by the absorption of sinus venosus. How left atrium smooth part forms through absorption of 4 pulmonary veins. I have already explained about this sinus venosus, horn fate, right horn fate, SVC and IVC, left horn fate, coronary sinus, left common cardinal vein fate is oblique vein of left ventricle. Okay. Now we are going to discuss about atrioventricular wall development. Atrioventricular wall development. How atrioventricular wall, which are known as mitral wall and tricuspid wall. Mitral wall is also known as bicuspid wall. And closure of this mitral and tricuspid wall produce S1 sound, which is M1 and T1. Purpose of this mitral and tricuspid wall is this, that atrial blood can go into ventricle during diastole or ventricular relaxation time. But during ventricular systole, this blood cannot move from ventricle to atria because these valve purposes, they gives only unidirectional movement of blood. How the valve forms? Question is how the valve forms embryologically. First there is development of dense mesenchyme. This black one is dense mesenchyme at the junction of primitive atrium and primitive ventricle. This primitive ventricle is now bulbous cordis. This is bulbous cordis and this is primitive ventricle, bulboventricular cavity. Okay friends? At the uppermost part of this bulboventricular cavity, there is formation of what? There is formation of dense mesenchyme. Under the influence of this dense mesenchyme, this compact myocardium start hollowing like this. They start hollowing. Because of this hollowing, trabecules formation start like this. This is the hollowing. This, please see this hollowing. Because of this hollowing, there is formation of this trabecules, which are known as now trabeculae carni. And thin part, the dense mesenchyme is attached via this thin cord-like structure, this pinkish one, and this thin cord-like structure is known as chorda tendini. And the lower pole of this chorda tendini is attached through this spongy mesenchymal tissue, spongy myocardium, which is now known as papillary muscles. Hence, further development, these papillary muscles starts appearing completely, and they are connected through this chorda tendineae to this dense mesenchyme, and this dense mesenchyme starts detaching from this bottom part and form a valvular like structure, and forms this AV valve. So in nutshell, this AV valve is formed through dense mesenchyme and hollowing of ventricular musculature, and finally they forms chorda tendineae, trabeculae carni, and papillary muscles, and finally they form this bicuspid valve and tricuspid valve. This is bicuspid, which is actually connecting left atria to left ventricle, and this is right atria to right ventricle, tricuspid valve. Now we are going to discuss about ventricular septal development. How ventricle septum development? Ventricle septum develops through three parts. First part is muscular part. Please see carefully. This is muscular part. Second part is infundibular part. This is infundibular or outflow part. This outflow part is developed through bulbus cordis. Okay, friends? We are aware that two heart tubes form single heart tube like this. This single heart tube starts dilatation and constriction. Lowermost part is sinus venosus, then primitive atrium, then primitive ventricle, then bulbus cordis and truncus arteriosus. Bulbus cordis and primitive ventricle forms right ventricle and left ventricle. We are going to focus about this area. This is the bulbus cordis and primitive ventricle, and above it is connected through truncus arteriosus. First of all, at the floor of ventricular cavity, which is now known as bulboventricular cavity, at the floor of that cavity a septum starts appearing. This septum is known as muscular septum or ventricular septum, but it do not touch this endocardial cushion, so there is gap remaining. Now what happened? I am going to explain one more part, important concept about bulbus cordis. Bulbus cordis have three parts. Lowermost part forms right ventricle. Mid part form ventricular outflow septum, or outflow part of both ventricles, and the uppermost part of bulbus cordis form bulbar ridges and forms a part of spiral septum. Okay, lowermost part forms the right ventricle, mid part forms outflow tract or ventricular septum, and the uppermost part forms spiral septum. This is the lower part of bulbus cordis, which forms right ventricle. This is the lowermost part of bulbus cordis, which is forming right ventricle. What happens with this mid part? This mid part of bulbus cordis forms a septum which is dividing the outflow part of ventricular cavity into two parts. This is the right outflow part and this is the left outflow part. Right outflow part is now known as infundibulum or conus arteriosus, which will connect right ventricle to the pulmonary trunk, right ventricle to the pulmonary trunk, while left outflow part is known as aortic vestibule, which will connect left ventricular cavity to the aorta or aortic tube. Still, it is developing toward downward direction, but it do not touch the endocardial cushion. This is the endocardial cushion. Hence, this is not a complete septa. We have made two septas, but even with these two septas, a complete dividation between left ventricular cavity to the right ventricular cavity is yet not made. To complete this septa, proliferation in the atrioventricular cushion starts developing. Proliferation from the atrioventricular cushion or endocardial cushion start developing. Endocardial cushion start developing. This part of ventricular septum is known as membranous septum. What is this? Membranous septum. This was muscular septum, muscular part. This was bulbar part or infundibular part. Infundibular part. And the third part is membranous part, which is very important. Membranous part. To understand this membranous part development, please see this diagram very carefully. This is primitive ventricle attached to bulbocordes, and this bulbous cordes is draining blood to truncus arteriosus. We are aware. Truncus arteriosus will form future pulmonary trunk and aorta. Pulmonary trunk is anteriorly and aorta is posteriorly. I will explain it later. This is right AV orifice and this is left AV orifice, and this is the fused AV cushion. What I explained previously, that a muscular septum starts developing, which is known as interventricular septum. It do not touch the endocardial cushion. From upper side, from the bulbar septum starts developing, which is dividing outflow part into two, right outflow and the left outflow through bulbar septum. This is the bulbar septum. This gap is filled via endocardial cushion development. This gap is filled via this endocardial cushion proliferation, which is known as membranous part. This is known as membranous part. This membranous part have two portions. One is anterior and posterior. I am not able to visualize in this image, but this is the anterior septum, which is connecting this muscular part or interventricular septum and divide left ventricular cavity from the right ventricular cavity from the left ventricular cavity. And the posterior part of this endocardial cushion, which is in posterior of this screen, is getting attached to the bulbar septum. This is the bulbar septum. And finally, this divide right atrial cavity from the left ventricular cavity. Please look very carefully. Right atrial cavity is divided through left ventricular cavity through ventricular septum via posterior fold of endocardial cushion, while from anterior fold it is dividing right ventricular to the left ventricular cavity. Now our ventricular septum is complete. I am going to repeat again. Ventricular septum has three parts. Muscular part, which develops from myocardium or floor of myocardium of bulboventricular cavity. Second part is bulbous part, which is also known as infundibular or outflow part, which is dividing outflow part of ventricular cavity into two parts, right outflow and left outflow part. And third is endocardial cushion proliferation, which is actually membranous part of ventricular septum, membranous part of ventricular septum. Now we are going to discuss about spiral septum development or conotruncal septal development. This spiral septum developed in truncus arteriosus. This is truncus arteriosus. Where was this truncus arteriosus? If you are aware that truncus arteriosus was the superior most part of heart tube. Superior most part of heart tube, which was known as truncus arteriosus. This truncus arteriosus is divided into two parts, pulmonary trunk and aorta, in such a manner that pulmonary trunk is initially anteriorly, then it goes to the left side, and finally it goes to the posterior side, while aorta, which is initially posterior, goes to the right side and then to the anterior side. We will develop spiral septum in few minutes, but please see what happens after development of this spiral septum. If you look aorta, which is initially posterior, I make a spiral septum through three pieces of paper. This is first piece of paper. This is another piece of paper which is actually perpendicular to this two laptop, which is perpendicular to this laptop, one laptop, second laptop, and this piece of paper is perpendicular, which is dividing right and left half, while these laptop are dividing in anterior and posterior. Okay guys, the lower portion of septum and the upper portion of septum is dividing tube into two parts. One is anterior, another is posterior. We are not able to visualize. If you look what happens, this aorta is initially posterior, then it comes to the right side. This is the right side. Then it comes anterior. Finally it comes anterior. What happens? Aorta is initially underneath. Aorta is initially underneath or posterior. Then it comes to the right side, and then finally comes anteriorly. Finally comes anteriorly. What happens in case of pulmonary trunk? Pulmonary trunk is initially anteriorly, then goes to the left side, and then finally it is going to the posteriorly through this spiral septum. So how this spiral septum is forming, this become a special question of our mind, how this spiral septum forms. Okay, this spiral septum is having three septas. This is clear in your mind, because our orientation is this. First we will make this septa, then this is the perpendicular septa, and the third septa is this. These three septas we will form. First of all, right superior truncal ridge, and the left, this is the left inferior truncal ridge forms, and they meet each other in such a way that a spiral septum forms like this. This superior ridge and inferior ridge forms in such a way that a spiral septum forms in this way. Because of this spiraling, what happens in the lowermost part and the uppermost part, it divides tube into anterior and posterior side, while at the mid part, which is developed through conal ridges, this is the mid part, into right and left half. Okay friends, in this diagram I am showing aorta is initially posterior, then comes to the right side, then anteriorly. Because of this spiral septum, this is the spiral septum. This is the spiral septum or corkscrew type of septum. Please see, the purpose of spiral septum is this: aorta is initially posterior, then comes to the right and then anterior, while pulmonary trunk is anterior initially, then going left side and then goes posteriorly. Because of this three septa formation. Lowermost is truncal ridge, this is conal ridge, and this is superior truncal ridge. This lower truncal ridge is also known as bulbar ridge. If you see carefully here, this conal ridge is developing in the anterior posterior direction, so it divides into right and left, while these uppermost and the lowermost truncal ridges are developing through lateral, so they will divide in anterior and posterior. This is the anterior and posterior. In the initial part, pulmonary trunk is anteriorly situated. This is anteriorly situated. But in the next segment, this pulmonary trunk is shifted toward left side. This is important concept because when we will read about pulmonary valve development and aortic valve development in next diagram, I will explain this concept again, that pulmonary trunk is initially in the anterior side, then going to the left side, while pulmonary trunk aorta is initially posteriorly, then going to the right side. How it is possible? So please read this. In this I am showing development of aorta and pulmonary valve development. I have explained that what happens, these two ridges, these are the conal bulbar ridges, these bulbar ridges, please see here, these are the bulbar ridges. These bulbar ridges are developing in the lateral directions. So these bulbar ridges, these are the bulbar ridges. These bulbar ridges develop from the lateral swellings, and they meet each other. They meet each other in the central part. When they meet each other, same time, two more swelling starts appearing. One anterior swelling is known as ventral valvular swelling, and the posterior swelling is known as dorsal valvular swelling. We are aware that the anterior part is pulmonary trunk, while posterior is aorta. Now what happens in the upper part, in the just next segment, which is actually conal segment, this is truncus arteriosus, this is bulbar part, this is conal part, and this is truncus arteriosus part. Valve start appearing in this bulbus cordis or conal junction. So when conus part appear, here is the right side, what happens is this aorta is situated, while in the left side what is situated, pulmonary trunk is situated. Okay, so what happens, this anterior part have to shift in the left side, while this posterior part, which is having aorta, have to shift in right side. So this happens via anti-clockwise rotation after complete fusion. This anti-clockwise rotation bifurcate it from the mid part like this, and both these valves take their definitive position. The aortic valve goes posteriorly and to the right side, and this pulmonary valve come to the anterior and to the left side. And the catch point of this discussion is this, that this pulmonary valve have one anterior valve. See, anterior swelling, this green one. Pulmonary valve, this is the pulmonary valve. This pulmonary valve have one anterior swelling, while this aortic valve this aortic valve have one posterior swelling and two remaining bulbar swellings. No question. Catch point is this: A has one P has one A. Means aortic valve has one posterior swelling, pulmonary valve has one anterior swelling. As this is tricuspid valve, all aortic and pulmonary valve has three cusps, but tricuspid. So if we are aware that one cusp coming posteriorly in aortic valve, then the two remaining will be the anterior cusp, which are coming from the left half or right half of bulbar ridges. Now, how these aortic and pulmonary valve develop? First of all, there is valve swelling. Simple. This valve swelling starts thinning, and because of this thinning and hollowing, they start hanging upon this lumen. And finally, more hollowing occurs and more thinning occurs, and finally these swelling form valve cusp. If this is aorta, if we assume this is the left ventricular cavity and this is aortic cavity, then aorta have one posterior wall. This is the one posterior wall, and here is two anterior wall. Okay, friends. This posterior wall develops from this posterior valve swelling, while these two anterior valve cusps develop through this right and left half bulbar ridges. One important concept I forget, where SA node, AV node, his bundle, right branch, left branch, and Purkinje fibers appear, or the conduction system of heart, from where it developed. If you see this diagram very carefully during initial of my discussion, then I told that I will explain it later on. Now it's time to discuss this diagram as well. Sorry for delay, but I want to make a very special image in your mind so that whole concept get clear. This is, now you are aware that the lowermost part, which is sinus venosus, this was the lowermost part which is having sinus venosus, and this is primitive atrium, then primitive ventricle, bulbus cordis, then truncus arteriosus. After folding of this tube, folding or looping of this tube, this forms four-chambered heart. But at the 22nd day, heart starts beating. Means it starts pushing its blood from lower end to the cranial end. Why it get happen? Because this sinus venosus cell, because this lowermost portion of sinus venosus cell have conduction abilities. Because of this conduction abilities, when heart is taking its definitive position in like this as four-chambered heart, the lowermost portion of septum sinus venosus finally get attached with the visceral pericardium initially, and most of the sinus venosus comes in the right atrium, where it forms SA node, AV node, then this bundle of His, right branch and left branch. These all are formed through sinus venosus. Now the time to discuss about Purkinje system, Purkinje fiber. These are modified myocardial cells. Okay friends, these are modified myocardial cells. So please discuss few questions before end of our this heart development. Sinus venosus receive blood. Simple. Three set of vein, Witti, Umbi and common cardinal. Derivative of Witti form IVC. Simple. Septum secundum arises from atrium. Simple. Superior vena cava develops from simple right anterior cardinal vein. Just revise in 5 minutes, another 5 minutes. I am taking more 5 minutes. First of all, this is coelom develops around 15th to 16th day. After development of coelom, cardiogenic area appears. This cardiogenic area will form angioblastic cord cell in the splanchnopleuric mesoderm and the lateral plate mesoderm. Everything is question. Same time, vasculogenesis also appears, which will form dorsal aorta and angiogenesis. We will discuss in the next lecture about vasculogenesis and the vascular development. But right now, focus about this heart tube. Two heart tubes on 18th day form around 20 day they will form the single heart tube. After dilatation and constrictions, they will form sinus venosus, primitive atrium, primitive ventricle. This is bulbus cordis, and then truncus arteriosus after 5 dilatations, which is connected to dorsal aorta via aortic sac and aortic arches. In this diagram, I explained about atrial septal development, which is here. This is septum primum, which is having on the upper pole foramen primum, then foramen secundum. This is septum secundum. And the right atrial development I explained about SVC foramen, this is IVC foramen, and this is coronary sinus foramen. And the smooth part developed of right atrium developed through absorption of sinus venosus, while the smooth part of left atrium developed through absorption of pulmonary veins. Ventricular septum have 3 parts. Muscular part developed through the bulboventricular ridge. This is the muscular septum. And this is the bulbar septum, which is dividing outflow part of both the ventricles. It is developed through bulbus cordis. Yet one more septum is required, which is developed through proliferation of this endocardial cushion, which gives anterior and posterior. I have explained anterior endocardial cushion divide right ventricle from the left ventricle, while the posterior divide right atria to the left ventricle. This endocardial cushion proliferation is known as membranous part of ventricular septum. Please, thank you so much for patience listening about development of heart. Thank you so much.